beginning today, we're looking at functions. The good part about using functions is you've already been using them. So we don't need to say that this is the first time you've ever seen them and you're freaking out about, oh my gosh, I have to use a function. What do I do? You've written functions and you've called other functions. So you've actually used functions and you've constructed functions. So this, in that technical sense, is not new, but because you were just following along and weren't really aware of what we mean by function, it wasn't necessarily something that you were quite aware that you were doing. But when we used our different items, so we use setup or draw, these are functions, and they exhibit all of the characteristics of the default for a function that we need to use and how we put one together. Now, when we specify something like background, and I then put in a color like this, I am now calling a function. So I'm calling the background function and passing a parameter to that function saying, hey, by the way, Mr. Background, would you color yourself with the color white? And it says, sure, no problem. Hey, thanks for giving me that info. Because if you just said background, I'd be like, dude, I don't know what you wanted colored. It's not working. And it'd be all grumpy. And we'd have error messages and highlighted code lines that make no sense and just general unhappiness. And we don't want that. So when we're looking at this, we have a function. We're constructing one. Void setup, parenthesis, close parenthesis, curly brace. Then my next line, background, is calling a function. It's calling the background function. And then closing curly brace. So why do we want functions? Why do we care? The reason that we use functions is they allow us to compartmentalize or create portability to our code. It makes your code modular so that it's now chunks. If you think in terms of building blocks or Legos, if that's where your brain goes when it comes to constructing things, that's where my brain goes because my house is overrun with Legos, that with that, if I put everything into a nice, neat, easy-to-use module, I can now take modules from one project and mix them with the modules in another project without having to rewrite everything. So if I help to organize my code into well-thought-out modules, or more appropriately called functions, I'm able to then be much more efficient while I am programming with my code. So these are pre-built, they're hard-baked into the language, setup and draw. I could just as easily construct my own function. So I could say something like void draw red circle. And once I've done that, I can now say fill 255, 0, 0, and ellipse. Width divided by 2, height divided by 2, 50, comma 50. And then this would draw a circle. Now, if I were to run this sketch, I would run into a little problem because I am trying to access width and height before I've provided a size for my document. So do always remember, part of the general format that we always need to do is specify the size of our sketch. So I've now constructed a function here, and we will keep talking about exactly what is the format of a structure of a function, how do you have to do it, what's required, what's not, and what the different pieces all mean. Hopefully that's going to become more and more clear as the afternoon progresses. So right now, I've constructed a function. Now, if I were to run my sketch, I'm going to just add in one more line just to prevent the error message from possibly occurring, and I'll just put in my size specification. So I at least specify a size, specify my starting background color. I mean, that's just considered good practice. If you don't do that, you get the default 200 by 200 sketch, and you're just being lazy if you don't put in a size designation. So I have void setup, void draw. These are the two default functions. Setup runs once and exactly one time. Draw will run every frame that my program is running. So if it's at 60 frames per second, 60 times per second, the draw function is going to execute or do whatever's inside that function. Then I have draw red circle. So now what we can do is run this and see what happens, and it comes up, and I will see an 800 by 600 white filled sketch and no red circle. Right, so now the red circle shows up after much discussion, puzzlement, confusion, another difficulty. So draw red circle now shows up because I can write all the functions I want, but if I never call them and say, hey, Mr. Function, would you do what you're supposed to do? If I don't call it, it just sits there twiddling its thumbs and is bored and sad and lonely, saying, what about me? So I have to call it. So what's going to happen on your projects is we're going to start organizing it so your draw function is only going to just call a whole bunch of different functions, but the draw function isn't going to have lines upon lines where it's like draw this rect, draw this ellipse, draw this line, change this fill color, change. We're not going to put any of that in the draw function anymore. The draw function is just going to call the chunks of code that we want in a much more organized manner. It's going to make your life so much easier. So when you start looking at the 1 to 2 to 3 to 400 lines of code that you'll be writing, if it's just a whole bunch of lines of instructions to the computer, that's hard to keep track of. When it's organized into a function, and the function may only be 5, 10, or 20 lines long, it's much easier to go, oh, that's what this group of lines of instructions are telling the computer to do. So it becomes much easier to start to process and understand what is happening inside our projects when we have it organized into a much cleaner, easier version. So this now draws a red circle, la-di-da. That's not really very exciting. So we're going to add to this and hopefully make it a little bit better. So I'm going to take this circle and we'll leave it in the background, and we're going to add another element to our sketch, but this element is going to be animated. So previously, what we would have possibly done is we would say something along the lines of float x. One thing that you can do when you're defining your variables, I don't know when the book goes over showing you that you can do this, but when it's the same kind of variable, I can go float x, float y, speed, then float speed x, like this. But if they're all floats, what we can actually do, if we want, is the same kind of objects can all be defined on one line. That can sometimes make your code a little bit easier because it's not uncommon as your projects are going to grow in scope and complexity that you'll probably have 20 or 50 or 100 different variables that are part of it. And if you now have them grouped by type on a single line, that can make it, not always, sometimes it will make your code less readable, but often it can make it a little bit easier where we can see like x and y, yeah, it makes sense that they're in the same line, and then speed y. So we have these different values that are going to be here. So I have an x and a y and a speed x and a speed y I'll be working with. Now when it's number values, if we don't define them and give them an initial starting value, processing as a helper, and it goes, oh, well, I assume then you wanted them to start at 0. So if we don't give x and y, speed x and speed y initial values, it just defaults them to a 0 value, and then I can start using them. Not all languages are that forgiving. So some languages, if you don't give them a starting value, then they will give you error messages. I remember talking a little bit about this last week, but it's just important to remember that. So this time I'll set my x equal to 100, y equal to. Now when I'm assigning values to things, I can't do that on one line. So the way that I did x comma y comma, I can't do x equals 100 comma y equals, they have to be on separate lines. That is one requirement So speed x is equal to 5. Speed y is equal to 5. Those are all arbitrary numbers. They could be whatever makes you happy. If you made your sketch a different size, of course, you would choose different starting positions for your x and y appropriately. And now I'm going to set a color for this, and I will make this a green box that I'm going to work with. So I will choose 0, 255, 0. So just choosing radioactive default electric green. Correct. X comma y comma, let's just go 50 comma 50. Make a nice little square. Now if we run this, speed x and speed y aren't updating, so there's no change going on, but we can at least see, okay, square appears. Again, test early, test often, run your code, add in a few lines, run it, add in a few lines and run it. Don't get to the point that you type in too many lines of code and then you hit run and it breaks or fails or just gives you an error message, and then you're like, where's the problem? Is it in your variables? Is it where you defined their values? Is it where you implemented them? Too many lines of code will make it hard to figure out where the problem lies. Okay. So now we can go x plus equals speed x, y plus equals speed y. Now if I run my sketch again, we'll see that it now moves across the screen. Whoa. And it's still going. And it's not stopping because we have not bothered to look for the boundaries. I also have not bothered to kind of clean out the background or refill the background with white so that it looks like the object's animating, so we are seeing the trails. But, well, these are all easy things that we'll deal with momentarily. So we're doing the basic animation just like we did a few weeks ago. I have x and y properties, speed x and speed y, so my objects can move diagonally. And then we need to go through and say, I'm just going to separate the circle from that. Now if I say if x is less than 0 or x is greater than the width of my screen minus the size of my box, which is 50. So I should have set that 50 as a variable. So if I wanted to change the size of my box, I could change it here. But I'm going to just leave it for now and know that it's not quite ideal, but all right. So if that's the case, speed x is going to be times equals minus 1. So speed x starts out at 5. If I hit one of the boundaries, it reverses it to a minus 5. If it's now minus 5, when it hits a boundary, it becomes 5. So that allows me to keep making it become positive or negative, so I get the bounce effect, the billiard ball bouncing off the bumper kind of situation. Now we can repeat that again for y less than 0 or y. I'm trying to be good about putting in my spaces today to make it more readable. Speed y times equals minus 1. So this will now create a situation that my box is going to keep bouncing whenever it hits any of the boundaries. And once again, we'll test it and verify that we're on track. And we can see that it's now bouncing around. Sometimes it's fun when we don't erase the background because it creates interesting patterns. Now what would be interesting is to change it so that perhaps x and y aren't equal values. We could also change it so that we don't start at the same point. Oh wow, I've now made a pretzel. This is kind of cool. And it looks like progressively it will fill the screen in. It's kind of neat. All right. So we can see we're drawing the object. We're updating the position for the next go around. And then we're checking to see, do we need to change our speed because we hit a boundary? So we're checking our boundaries. So these are all very kind of common things. Now, if I don't want that kind of background, if I want it to look like the box is just moving, then I could say fill my background with 255. So if we run it again, we'll see that now we just see the box moving. I won't get the cool pretzel effect anymore. But now it does seem that the box is bouncing around on screen. So this is how we did it previously. As you can see, my draw loop is starting to get kind of cluttered. What we want to do is we want to have a little better way of working with this so our draw loop does not get so cluttered, because as our objects become more than a simple box or triangle or circle, as our number of objects increases from 1 to 2 to 3 to 10 to 100, this is not going to be a sustainable way of coding. So we're going to need to come up with something better. So moving forward with this, currently I have now it draws my red circle and then it draws my rectangle and then it updates its position. But what's really going on here is I'm doing a couple of different things. So draw red circle is now encapsulated into a function where it sets a fill color and then it draws a circle. So we could really do a similar kind of thing with our rectangle. So what I could look at on the rectangle is having, let me just move this up on screen a little bit more. So instead of just drawing red circle, I could say void update, and I will explain why I'm choosing the name that I'm choosing here. So I can have an update, and then I'm going to have a display. And again, don't forget your curly braces. So I have an update and a display. My update, I could say update rectangle and display rectangle, but I'm going to leave it more generic because when we start doing some stuff later on this afternoon, it will make more sense why I just wanted it a plain update and a plain display. And we'll hopefully understand it. So all I've done is add in 2 new function definitions, but they're not doing anything yet. Now, with that, we can make them do something. And to make them do something, everything I need to put inside these is already written. If I look in the code that I have here, 2 lines are about display information, my fill color, and draw the rectangle. So those 2 lines make sense to be under display. Now update. I'm updating my x, I'm updating my y, and I'm updating speed x, and I'm updating speed y. So that would make sense for those lines. So I can cut those and move those down to here. It would make sense for those to be in my update. So I have an update, and then I have a display line. And my draw function then will say update and display. So I've now organized, I'm going to get rid of these extra spaces just to tighten it up even a little bit more. I've organized my code so that my draw function is now just calling other functions. And then those functions are nice organized things that are essentially doing one activity. So the activity in display is I am now displaying my rectangle. I set the color and then I issue my rect command. The activity in my update is I'm updating my different variables that I have. I'm updating x, updating y, updating speed x, and updating speed y. Of course, those two only update when it's appropriate. So I have an update and I have display. So I added these two functions. My draw got a little bit cleaner. And then if I run this, I should see no change. It should still just run. But the advantage here is we're now well on our way to having significantly organized and made our code both more understandable and easier to use. Key thing to remember is a function should really just be a single topic activity. My update is updating the different variables that are present in my sketch. My display is now displaying that object that I want it to display. That's it for a little bit of this. So update and display can be named whatever you want them to be named. It's just very common that update and display are being used. We could use move in place of update, but under update, sometimes we're updating more than just simply an x and a y property, and that's really what we're referring to when we'd say move, is we're updating position, but perhaps we're also updating which piece of artwork is being displayed. We're updating health. We're updating more properties than just simply position. So to call it move might be a little bit limiting. So that's why update is a more universally used kind of term. Display is not always used. It works well in processing, but in some languages, display is already hard baked into the language as a built-in function or term. So because it's already defined in the language, if you try and use it, then that would cause conflicts, because are you referencing display built native in the language or your own function display? And then the compiler trying to make sense out of your code gets a little bit confused. So display doesn't always work. It depends on what language you're using on whether it accepts it or not. So you have to kind of figure out what's going to work. Sometimes you could use the word render, but render is in processing, so we can't use render here, so we use display, and then it does work. So update and display are the two words of choice that I'm going to encourage you to adopt as we use this method for visual programming this semester. So right now, I have my rectangle or box or whatever it's going to be, and it's bouncing around on screen. And if I want to turn this into something where I could have now more than one on screen, well, if I want more than one and I want them at different positions and I don't want those positions related to each other, then I really would need an x1 and a y1 and an x2 and a y2 and a x3 and a y3. And then I need a speed x1 and a speed y1 and a speed x2, because I don't want when one hits the wall to have all the objects change direction. It's not Space Invaders, where you have a universal where either everybody's going one way or everyone's going the other way. But if you look at the classic video game, arcade game Space Invaders, when one alien hits the wall, all the aliens switch direction and bounce over. So there we would have one speed x and one speed y. That would apply to everything. But otherwise, if we want the objects truly moving independently, each object really needs to have its own x and a y and a speed x and a speed y. And we'll look at how to add those properties to a given object. And that's what we're going to introduce next as we look at classes. So one final word about functions is that when we look at a function, so far all the functions we have written have the word void on them. Then we have a name of a function. Setup and draw are already built into processing. Update and display, draw red circle. I created those names. Then we have parentheses, then a curly brace, and then a closing curly brace to match up with the opening one down at the end. That's the basic structure of a function. The void means this function does not return any value. All it does is execute the lines of code contained within it. If I wanted a function that was returning a value, then I would specify, instead of void, I would specify what is it returning. And there's not a lot of cases where we have to use functions like that. We're not going to encounter a lot of them during the duration of the semester. But it sometimes might be nice to know your book goes into it over the course of a couple pages, stressing how important it is. And I can't think of a single example later on in the book that actually ever uses functions that return anything other than void. But the way that it works is perhaps I would say integer. So my function is going to return an integer. So I'm just doing this for demonstration, and then you can just see what it looks like to have a function that doesn't return void, but it's not going to actually be used or do anything inside my project. So if I say integer, and then I could say add actually 3 numbers, and then say int a, comma, int b, comma, int c, curly braces, and then say int total is equal to a plus b plus c. And then we say return total. So what would happen is if I wanted to use this function, I would then tell this function, hey, here's 3 numbers, would you add them together? And then when it runs, it gives me back that value. That's what it does. And there is actually, we make functions that return a Boolean. They don't return a number, but they will return a Boolean. So we will be actually using that, possibly. We don't have to, but there are some cases where it can make sense to do so. So there is a return type of Boolean that we could look at, but we're not going to worry about that today. So this now, it says my function is add 3 numbers. It'll take a, b, and c as arguments. These are called arguments up here. And then I have this variable total. And total is going to add those together, and then it will return the total. If a function does not say void, at the end of the function it must say return. And it must return an item of the same type as is specified in the return type. So this is the return type. This is the function name. Inside the parentheses are called arguments. Then I have the guts of the function. That's my term, not the fancy proper term. The lines of instructions contained within the function, I will call it the guts. Then we have the guts, and then we have a return statement that returns an item of the same type as was specified as a return type. That's why it's called a return type. When we say void, void means nothing, so our function is not obligated to return anything. Because if it had to return the same thing, we would say return void. Well, I just said return nothing. Well, if I'm returning nothing, there's no point in putting it in there, so we don't need to. So that's the final word on functions. It is what it is. We will do a little bit with return types as we do some more complex things, like say we want to do collision checking. We want to find out, did one object collide with another object that we're animating on screen? And if the answer to that is yes, then we want something to happen. And it's possible to write that collision detection into a function. It makes our code a little bit neater if we do that, but whatever. If I want to use this line that I have here now, I would say add 3 numbers, 5, 7, 8. Like that, and then it would spit back something, but I would actually have to be asking for it. So I would either have to say print line like this. And we know that the answer to this then would give me an answer of 20. So it would print out like this. If we run it, oh, but I can't just stick it down here. I need to go put this somewhere. I'll put this. I'll just put it up here and set up. It only needs to run once. So if we call it and name our function correctly, and try and access it at a proper place, then we're able to do so. So this now passes the three parameters, 5, 7, and 8, the three integers that my function is looking for. Now if I tried to pass into it a fractional or decimal number, say like 0.5, then it would fail because 0.5 is a floating point number, it's not an integer. So then I would be trying to pass the wrong kind of object into my function and it would be unhappy with me. That's just how that part of it works. So that's kind of the end all be all on functions that we need to worry about right now. It's not... The more you use them, the more they will keep your code organized. Remember, the general concept is a function should do one primary task. If you find a function is doing a whole bunch of different things, you probably could break it into multiple functions. Now, if I look at this, I have both updating x and y, but then this section here is really about have I hit my boundaries. It's not uncommon to actually have a function called check boundaries that checks to see has an object hit the boundaries. And if so, then it updates those values. So we can subdivide that a little bit more. And as our projects grow more complex, we often want to really put everything into very tidy little functions because it just keeps your code much, much more readable, provided you've named your functions intelligently. If you name your functions with just weird, random, or crappy names, then it doesn't do you any good, and it's hard to make sense out of your code. All right, so the next thing we're going to look at is playing with objects. So when we're making a class, we can add the class to the bottom of this document. So we can just add a class inside this document, and our document just keeps getting longer as we add more classes inside the file. A class file can also exist as a separate document. So it can be a separate one as long as it's in the same folder. So when they're in the same folder so that the sketch can find it, then all is right with the universe. So you can do it in a separate file, or you can do it in the same document. I'm going to leave it in the same document right now, and then at the end I will break it into a separate class file and save it out accordingly. Now, one word about this is classes have a number of conventions and some syntax that we are required to adhere to. The syntax we have to adhere to, conventions, good practice. By convention, classes always begin with a capital letter. So that is a normal thing. Way back in week 1, I talked about string versus character, and I said that we have a primitive data type, a character, but then we have the string class. And string had a capital S, where character and rect and all these other primitives all had lowercase letters. That's because string is a class. So it's a little bit different. So if I want to make a class, I'm just going to get so I can start a little higher up on screen here. All I have to do is type in the word class. So I'm telling processing, hey, look at, I'm doing this. And then this class I'm going to refer to as my big box. So that is my class name. Then I do a curly brace. Throwing a few extra returns in there so I know I have make sure I have an ending curly brace. So now I've defined the class. Within the class, there are 3 sections. And I'm putting in a whole bunch of extra comment marks here before I type it in. The first is going to be the data for the class. And then the next portion that we will have will be our setup for the class, sometimes referred to as our initialization for the class. And then we have our methods. Now the methods of the class are just simply functions, but when we have functions inside a class, we call them methods. So within the world of programming, a method is a function. A function is not necessarily a method. A method belongs to an object. It is a function, but when a function is part of an object, it's referred to as a method. So when you find blogs online, it'll be a tutorial and someone's talking about blah, 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 programming this, blah, 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 and there's all kinds of weird things and your head spins and you see language and it will call it a method. You're like, but that's a function. Well, it's a method. A method, when it's a function that's part of an object, it now gets called a method. But when a function is standalone, it's called a function. So we can often use them interchangeably. So I might refer to my display function or my update function, but I'm really referring to the method. So the terms we will use interchangeably, but within the world of programming, we often will refer to a method when it's contained within inside an object. We refer to a function when it's not part of any single object. That's just convention. Now within the setup, I have my initializing section where I will list my class name. And I'll say big box, parentheses, and then I have my curly braces for it. So setup is your initializing function within it is going to be, this is your class definition. So if I look at this right now, if I were to run this, I would get 0 error messages. It wouldn't do anything either, but I would not get any error messages. It's important to notice that the class, you use the word class, lowercase c. Then you have the name of your class, starts with a capital. Then you have a curly brace, which at the end of the class will have a closing curly brace. And then I'll have a section for the variables that are unique to this particular object. And then I have my setup section for my class, where we get to bring everything together. So what I'm going to do is I'm going to migrate my animating box over to that. So if I go back to my initial part up here, I will see that I have my initial variables, x and y, speed x and speed y. Well, those apply to the box. So I'm going to move those into the box. What I'm going to do initially while I do this, I'm not going to delete things. I'm not going to cut things. I'm going to highlight and I'm going to copy, and then I'm going to comment things out. I'm going to leave everything where it was so we can see where things were and then compare where they've moved to. Now, when you're writing or creating your projects, doing it first without a class and getting something working, and then you migrate that into a class is a very common way of working. So don't think that just because now you've seen how to make a class, well, if I wanted to get a complex object working, I wouldn't spend a lot of time building a complex class, unsure if I was even going to succeed. I would just write in the code I need to see one version of that object working. Then I would construct a class and migrate the code into that class, so then I could use that as a template for creating multiple copies or instances of that class object. So from a programming standpoint, the exact way that we've developed it here today is actually a very good way to do it. Keep it simple. Once you prove proof of concept that it's working, then you go through and build the more complex structure. So I copied my variables, which now I will refer to those as my data. So there's my data. So I move those over there. Now I'm going to go copy these lines of code, my x and where they get values. Oh, wrong line. So x and y, speed x, speed y. Okay, they're there. And now we need to put a few methods in here. So we need to move the methods over. Well, the methods are really update and display. So now I have migrated my whole box out. Background, draw red circle. Now I have update and display. Now if I try and run my sketch thinking, yeah, I'm in good shape now, I'll find out very quickly that I'm not. And my code failed on line 16. It's telling me it failed on line 16. If I look at line 16, 16 called update. But if I look at what's going on, update is now inside my big box class. Update is no longer accessible to the main sketch directly. So that's a problem. So we need to make sense out of that. So once the class has migrated all of the content that was in my main sketch over, once I have that there, now I need to kind of bring to life a version of my big box. And I can do that by saying object type big box, my new awesome box. And I don't have any self-esteem issues either. I'm just letting you know that I'm okay. My new awesome box is a new big box. So previously we used float, we used int, we used character, string, boolean. We used these different data types. A class is simply a data type, and just because we made it doesn't mean we can't use it. Because we made it means we absolutely should use it. So I'm going to say my big box, my new awesome box. And if I add in, if I modify 2 more lines, then my project's going to work again. Just 2. Because my name is too long there, I'm just going to paste it in. So I said, my new awesome box. It's a new big box. And then I want to tell that object to update, and I want to tell that object to display. We are using what's referred to as a dot notation. So we say the object dot, and then the method we wish to access. The method update or the method display, we're able to update those. So if we run this, we'll be exactly where we were before we made the class, with no visible difference. So then you might be thinking, it's like, well, okay, that's fine, but now what if I want 2 boxes or 3 boxes or 4 boxes? What do I do? Display. So if I want a second object, I just type in a second object. Tell that object to update and display. Going back into the object where it has random x and y, random speeds. Now what we should see is each object now moving independently. So we have an object template, or class, and then we make new instances or copies of that object. Big box B3. B3 is equal to new big box. B3 dot update. B3 dot display. And I could continue this until I'm blue in the face, and then you will start thinking perhaps there is now a better way that you could go about doing this, and we will be looking at that next class. But now I should see 3 boxes all moving independently, but they're all now the same color. That's not very fun. So one item that we have not looked at specifically is how to specify a color as a variable or as an object for that So what we can do, currently now the boxes are filled with green. Well, another data item we could have would be a color. I'll just call it C. If we say C is equal to color random 255, so it's now a random color. So my box will be a random color. And then we're going to fill that box with that same random color. So we can specify a color by saying color and then specify our red, our green. So if you think about when we used fill or stroke before, where we'd fill and then list 3 colors. If we just say the word color, I've now, that specifies the color white. So my variable C is a color. It's not a float. And C is equal to color, and then I specify what it is. It will be random. Now when I run this, I should get 3 different random colored boxes, all moving with different speeds, and they all started at different positions. Each object has an update method and a display method. Now, if I didn't want these to be rectangles and wanted to change it to an ellipse, or I could have a rectangle and then I could even modify it. I could draw a rectangle within it. And I'll fill it with, just fill it with white so we see that it, no, maybe not with white. Fill it with, yeah, okay, yeah, red works. Do a second rectangle, and this time I will offset it, so I will say x plus 10, y plus 10, and then for width and height, we'll say 30, 30. So I've now centered a box inside the existing box. But what this is proving is that I can modify the display, and I'm not changing anything else. So this whole display, I could throw out entirely the whole guts of this display and replace it with a much more complex thing. So if you think about the little creature you made with arms and legs and eyes and noses and mouths, if you dump that into the display, modifying everything based on X and Y, then you're just moving forward and having lots of fun with it. So our class builds a template for our object. Then we create instances of it by specifying new in that type of object. And that is all it takes. So we can see, here's our initial variables, move those into the class. Now I'm going to finally get rid of them. Here are my initial assignments to those inside my setup. Well, now we move that into the function or into the class, get rid of it there. And here were the original versions of those functions. Get rid of those there because they are now methods contained inside a class. Class starts with the word class, lowercase c, then the class name starts with a capital letter, and then we have our setup or instantiation inside the class, and we reissue the class name right here. Inside these parentheses, we could have arguments, and we will talk about that next week. There's a nice explanation of those and the difference between parameters and arguments inside your book. Hopefully now that you've done a little bit with this, it will make more sense as you reread the chapter in the book trying to make sense out of it. But we will find a better way than just keep saying new, new, new. So if we want to add 100 objects, we don't want to say object 1, object 2, object 3, up to object 100, then object 1 update, object 2 update, object 3 update, object 1 display, object 2 object. Once we get more than a couple objects, we're going to be much happier with better methods, and that's what we will look at. And that's talked about using arrays, which are like file folders or a file cabinet where you just stick a whole bunch of things in a sequential order and you have them all nice and neatly organized and contained. And we'll talk about that next time.